Well, so continuing on the data science, Python for data science series, this is episode number 6, and we are getting started with Numpy. So Numpy is one of the library which you should always learn if you want to do work in the data science field. So it is the core fundamental thing which you should know in case of coding for data science, right? Okay, yeah, now let's get started. So NumPy is kind of a short form of a numerical Python. So this library is the core concept behind the NumPy is a n-dimensional array, right? So this n-dimensional array is very similar to the list which we went through in the last few videos, but it has certain advantages over list, like it is more compact, it has faster access in reading and writing items, the ease of element wise operations which you want to do, that is very much easier to do in case of NumPy, but in case of list it is much more time consuming and much more complex process. So we will see like what are the differences between list and NumPy when we are doing element wise operation, right? And NumPy also has certain inbuilt functions to do mathematical operations and also to do statistical operations on top of a certain data, right? Which is not easily available in case of normal Python list, right? Yeah, now let's get started. So if you have NumPy installed, then it's fine. Otherwise, you can straight away run this. You can uncomment this command and you can run this pip install NumPy. That will kind of install the latest version of NumPy within your system. Once the installation is done, you can import NumPy as MP. So that is the way to import the NumPy library into your programming console, right? Uh, then what you can do is you can create a 1D NumPy array. So this is the way to create a one-dimensional NumPy array. As I mentioned, the basic core concept of NumPy is n-dimensional array. So what we are creating here is a one-dimensional NumPy array. So if I print this, the output will look like this. So it has only one brackets, the third brackets, because it is a one-dimensional array. Now you can create a two-dimensional array also, right? So you can write like numpy.array, then you define this two-dimensional array. So this is first is kind of a list. Then after giving comma, you are again writing another list. So it will kind of create a two-dimensional NumPy array, which will have a certain shape and also a D type. D type here means the data type of this NumPy array, right? Okay, so if I once I define this NumPy array, I will print this NumPy array. You will look. So this is the output of this two-dimensional NumPy array. So you'll see here there are two third brackets to start the NumPy array, and also it ends with two third brackets, so it denotes that it is a, two-dimensional array. Now, if you print the shape of this NumPy array, you will see that the shape output is a tuple, right? And the first element of this tuple is the number of rows in that NumPy array, and the second element is the total number of columns in that particular NumPy array, right? So this you should always remember, the first element is rows and the second element is number of columns, right? And if you check the D type or the data type of this NumPy array, it's of type int32. So it's an integer type two-dimensional NumPy array. Now let's compare a few of the features which we get uh, in NumPy while we compare it with list. So let's first create a list. So this list is a integer list of three numbers, 1, 2, 3. The name of this list is my list. Now you have a requirement that you need to multiply each of the element of this list with 2, and you need to print that element, right? To do that in case of list, you need to do a lot of manipulations here, right? First, you create an empty list, then you loop through the list using a for loop. Then you do this multiplication with 2, and you append that value to this empty list, right? And then you can print that. So that after all these operations, each of the elements of this list will be multiplied with 2, right? Now you may think that we can straight away multiply my list with 2. So that will do the multiplication of element wise operations, right? But it will not happen in case of list. It will just repeat the values twice. So you see here, this is the output of my empty list, which where I have multiplied 2 for each of the elements of my list. Then I have stored that value to the empty list. And if I do this operations like my list into 2, it will just repeat the list twice, right? But in case of NumPy array, you can define this list. You can pass this list as an argument to the NumPy array creation, and it will create a NumPy array. And then you can straight away do this a into 2, and then you will get element wise multiplication with 2 for each of the elements of my NumPy array. And it's much more cleaner and it's much more easier to do in case of NumPy while compared to the list. Okay, now let's go into the mathematical operations. So I have defined here two NumPy arrays. So all these are one-dimensional array, A and B. Now, if you want to do a add, you can simply write this A plus B. So that will do the element-wise sum, right? So 4 will be summed with 2, 5 will be summed with 4 will be summed with 1, 5 will be summed with 2, and 6 will be summed with 3. So this is the output of this element-wise addition. Similarly, you can do this operation using this numpy.add. So it is the similar output you will get. Then you can also do a subtract. So the subtraction or the multiplication and division or the square of this NumPy array will do the square root here, which I have written here. So it will always do the element-wise operation. So you don't need to write a for loop, then loop through each of the elements of the NumPy array, and then do the operations, right? So that you don't need to do. So you can just simply do the mathematical operations, and it will do the element-wise operations, right? And similarly, the dot product, which we frequently use in case of data science, like if you want to do a linear regression from scratch or a logistic regression, or in case of neural network, also, if you want to do anything from scratch, you need to do a dot product between two NumPy arrays or two matrices, right? So this is the way to do it. NP dot. NP dot will do the dot product between these two NumPy arrays, one-dimensional arrays. Then you will also see that if you want to do any deep learning kind of operations where we are multiplying two of the matrices, right? So to match the inner dimensions, you need to transpose one of the matrices, right? So what you can do is using this np dot transpose, you can change the rows to column and columns to rows. So that will kind of change the shape of my matrix. So it is just transposing the matrix, changing the rows to columns and columns to rows. Okay, so these are the few of the syntaxes using which you can create several types of NumPy arrays. Like you can create NumPy arrays of zeros with this dimension. So you need to pass the dimension here as an argument. So this 2 by 2 means that you will have two rows and two columns of this NumPy n-dimensional array or two-dimensional array where each of the all the values are with zero values initialized with zero values, and this is how you can define. Similarly, you can create NumPy array with all ones. So here the dimension is 1 comma 2. So like 1 is the number of rows and 2 is the number of columns. Right. So similarly, you can also create identical identity matrix where the diagonal elements are 1 and rest of the elements are 0. And say that you want to create a NumPy array with random numbers, right? So you will see, like in case of deep learning coding scenarios, we want to initialize your weight matrices with random values, right? So this is the way you can create it. So np.random is the syntax, and then you need to pass what would be the dimension of my array of this, right? Here, this is 2 by 2 array where there are two rows and two columns, and the output looks like this. Now, similar to array, you can also do indexing in the NumPy array. So here you have a two-dimensional array which I have created, which has like four rows, three rows and four columns. So if I just check the shape of this, so you'll see there are three rows and four columns, right? Now the syntax which you need to remember for doing the array slicing in case of NumPy is um, this is the syntax you need to remember. So first you will mention the array name, then the row start colon the row end value and then comma, and then you will do it for the column also, the column start value and the column end value. And you need to remember as same as in case of list also, the row end or the column end value will be excluded. It will not be inclusive of these values. It will be excluding that, because also the indexing for NumPy arrays also starts from 0. Okay, now this is the way to fetch all the rows and all the columns from a NumPy array. Okay, now if you want to access the second row, starting from second row to all the rows and all the columns, right? So what we will do is you will mention one here and you will keep this blank. So the keeping this position as blank means you want to access all the elements starting from this element to the end of the number of rows, right? And if you keep both the elements null here in case of columns, it will fetch all the columns, right? So this is the way to do it. Now to access particular elements from a particular row, this is the way to do, like the fourth element from the first row. So the first you need to access the first row, and this is the way to access the fourth element. So to access the fourth element, you need to mention 3 here. And print the first element of third row. What you need to do is first you will access the third row by using 2 here. Then you will access the first element of that row, or first element of that row you can access using 0. So similarly, you can fetch all rows with second and third columns with this syntax. Now you can also do Boolean indexing in case of NumPy array. Now how to do that is first you need to create the condition for which you need to create the Boolean indexing, right? So first this is the condition, like I want to access all the elements from my NumPy array where the values are greater than 2, right? So that condition you need to pass inside this array as an argument. Then it will fetch all the elements from this where the value is greater than 2, right? So if I just print this a greater than 2, you will see um, here the outputs are coming as an true and false in the true and false values, and that we are passing as an argument to my array, and it will print this values. Right now, you can also change the shape of an NumPy array with this reshape function. So at first, my shape of my A array was, let's see what was the shape of that. So the shape was 3, 4, like 3 number of rows and 4 number of columns. Now you can change it to with the values of 2 number of rows and 6 number of columns, right? So to reshape the array, this is the command. Now you can also create equally spaced or evenly spaced numbers within certain range, right? So if I give argument of 24 within this a range function, it will create equally or evenly spaced numbers starting from 0 to 24 or 23, because 24 will be excluded, and it will print the value still 23, right? And if you check the dimension of this array, it's a one-dimensional NumPy array, right? So you can also reshape this array with, you can convert this one-dimensional array to two-dimensional array with this command of dot reshape, where you need to pass the number of rows and number of columns. And this function, which is a range here, I'm just creating equally spaced values starting from 10 to 20, and the spacing between those two numbers, or the spacing between 10 to 20, or the differences between the numbers would be 2, right? So my starting number is 10, then 12, and it will go till 18 because this 20 will be excluded from this command, and the output will look like this. So if I just check the type of this array, it's a NumPy array, right? Similarly, you can create uh, like number of samples within a particular range, and this 5 is the number of samples which you want to create between these two numbers, right? Between 10 to 20, I want to create 5 numbers, which are again has a equal space between them, right? So as I mentioned in the starting of the video, you can also do the statistical operations using NumPy array. So a few of the statistical functions which we will see, like at first we will create a NumPy array, then we can calculate the median of that array, right? Using this np.median. Now we can also create np.mean using which will create the mean value of this NumPy array, multidimensional NumPy array. Similarly, you can also calculate the variance and standard deviation using np.var and np.standard right? So that will give you the standard deviation or the variance for this whole NumPy array's variance and standard deviation will be printed as an output of this. Okay, so these are the very basics of NumPy operations, which you should be aware of to work with any data science problem. So yeah, that's all I have for this video. Thanks for watching.